All right, here we're going to consider the function f of x equals 5x minus 3. And so that's our original function over here on the right. Describe in words what the function does to any input. Well, the input is always x, and we multiply that by 5 first. So multiply by 5. And then after we do that, we subtract it by 3. Ta-da! Second thing, list the steps in order that will undo the function. Undo meaning like we're just kind of going the opposite direction. So instead of subtracting 3, we were going to add 3. So add 3, because that undoes this part. And then after that, we are going to divide by 5, because that would undo this part here. So just kind of doing the inverse operation and in the opposite order. Write an equation for the steps that you wrote in part B. Name this G. So we got G of x equals, we're taking something and adding 3, and then whatever that is, dividing by 5. There's our G of x. And lastly, what happens if you compose f and g? Use the function machine diagram at the right to evaluate g of f of 5. Explain why your answer makes sense. So let's talk about, okay, let me rewrite these really quick here. So for f of 5, I'm going to work inside out here. So f of 5, I'm going to plug 5 in for x here. And if I plug that in, I go 5 times 5, which is 25. 25 minus 3 is 22. So now that I have f of 5, I'm plugging in 22 in for that, which I'm really just plugging 22 in for x and g of x. So I would do 22 plus 3, which is 25, and 25 divided by 5, which is 5. Now, why does that make sense? Well, it makes sense because our g of x was undoing the original function. So we plug something in, a bunch of stuff happens to it, and it becomes 22. But then we undo all that stuff, and hey, we're back here to where we started. So it makes sense when we plug it in originally for it to pop back out what we started with.